You have the floor, sir.
Okay, thank you very much, Felix. I'm sorry for wasting our time. I was having issues with network. We all know Nigerian network, how it can be frustrating and that. So, today, today we're going to be talking about RAG, which is Retrieval Augmented Generation. Okay, I prepared some slides. Can I show slides?
Yeah, sure.
Felix.
Yeah, share your screen, bro. You have the floor. You have the
Okay,
tempo. You have the coordination.
okay. Okay, let me share my screen. Once you can see my screen, please let me know. Can you see my screen? No. No.
I
Can
can
you see
see
it?
your screen. Introduction to Retrieval-Augmented Generation, RAG, enhancing large language models with real-world knowledge.
Okay. So, without wasting much time, we're going to start right now. So, today's topic, we're going to be talking about introduction to retrieval augmented generation, right? So, before I go into what we have today, I want to just give a little bit insight on what this is what's actually all about. So, imagine a scenario you are you prepared for a mathematics exam, right? And you read some textbook and you read a lot of textbook. But then coming to the example, you saw questions. You guys you should understand this feeling when if you read some to the example, you abstract or yeah, something like that. So you try to answer the ones you can answer and possibly hallucinate the ones you are not sure of, but just to provide an answer for you to get a mark, right? This is what natural large language models does. So now with the introduction of RAG, which is retrieval augmented generation now. Okay, and let me change that scenario now. Now, picture another scenario where you are taking that same maths exam, but then you have a textbook in front of you, a mathematics textbook in front of you, and in that textbook it contains every informations concerning that particular maths exam, right? So it's more of like they're telling you, hey, this is this mathematics exam, number 1 to 60. Use this textbook to answer these questions. It's like giving you expo. So once you see a particular question, you try to search for the answer in the textbook. This is what RAG is actually doing. So retrieval augmented generation is just I've started explaining my main slide. Okay, let me just see what I want to say. Retrieval augmented generation is just having the retrieval system and having the generation model, the model that generating the answer. So without wasting time, let me just go to the next slide. So why RAG? The question, why RAG? What's the problem with LLMs? Why do we use RAG? So LLMs rely on only training data, which can be outdated. They hallucinate or make confident but false statements, just like I gave in the illustration, where you're in a max exam and you want to but you want to answer every question by all means, even though you don't know some of the questions there. You try to hallucinate or just to come up with an answer just or thereabouts. This is what LLMs are doing. They can't easily access private or real-time information. Right? So this is actually the problems with LLM. So this is why we are introducing is this retrieval-augmented generation, which is called, which in short we call RAG. So the solution, which is retrieval-augmented generation, RAG, like I said earlier, RAG is all about the retrieval system, and the generation model. The the LLMs allow these LLMs allow us to search for information before generating answer. Like I gave in the illustration before. What now you have open AI large language model, and now you have chunks of data you have stored in a vector database, and you are not telling the LLM to use this set of data and answer these questions using prompts. Right? So if you want to be good in retrieval in this applied ML system, you need to have you need to know how to write prompts. A good prompt is equivalent to a good prompt makes up, let's say, 40% of your RAG system. Once you know how to write your prompts very well, it makes up 40% of your RAG system. So RAG produces accurate, current, and verifiable responses. So now, like for instance, now, if something happened today, right now, and a large language model like ChatGPT, right, doesn't have access to the internet or things like that, and doesn't know what happened today, just what it only knows is what it was trained on. If you ask the question on something that happened, okay, like for instance now, I don't know if you guys heard about the the stuff that happened between Wiki and military personnel yesterday. So if it was something that happened immediately, right, and you ask ChatGPT, this, can you give me more information? The large language model doesn't know anything that happened because it was not trained on it. But now, if you have, okay, for instance, now it happened immediately, and you scrape data from the internet, and you paste it in a dictionary which you can be retrieving the context from to feed large language model. It can be able to tell you what happened because it is seeing the information and is using that information to generate response from you. That's just the power of RAG. So RAG system architecture, it's all about the user query, the retrieval system, the relevant documents, and then the large language model, and then the answer. The retriever finds relevant documents from a vector database. Vector, it's seen in this next slide, you see it, so let me not jump into it. Then the generator uses both retrieved information from the retriever and then the query to produce a response. Now, how it uses this information and these queries, it takes the embedded query, and then the embedded info, and then does something we call cosine similarity, where cosine similarity is the dot product between the two vectors, which is the query and the information, divided by the normalized distance of these vectors. That's the cosine similarity. It performs cosine similarity to find information that are similar to this particular query and uses to produce a perfect response. So the core components of a RAG system, we have the embedded model, which converts text to vectors. Example of embedded model, we have OpenAI, we have a lot of them. Then we have the vector storage, the vector DB, which stores and searches embeddings. Example of a vector database is we have the FIAS. This FIAS, the full name stands for Facebook AI search similarity. Yes, it was produced by Meta. Then we have ChromaDB, and another one I did not include there. We have Pinecone. So these are the three popular vector database.
Hello.
Yeah.
Please, since your screen is static to just one slide, and we cannot see like the rest of the slide that you are showing. Thank you.
You can't see this. You can't see my slide.
Like it's just currently at like introduction, and like we cannot have a feel of what you are showing us. It's just like stuck to that. Only like introduction to recover. Yeah.
Oh, sorry about wait. Looks like I'm just sharing a particular window. Wait, sorry.
You can actually see your mouse actually. It seems you are not changing the slides yourself.
Let me share my entire screen. Share my entire screen. Is it okay now?
We can see your screen. We are just like you're not moving your slides.
Is it moving now?
Yes, it's moving.
Okay. Sorry, I was just sharing a particular screen. Sorry about that. But what I've been saying since I've been making sense.
But somehow it makes sense, but somehow ambiguous.
Hello?
Hello, it's somehow ambiguous. Like there are some terms that I don't understand. Like I don't understand.
Now, how can parents balance
Can you hear me? Can you ever me reduce volume, please?
I can't. There's noise in your background. Be audible, please.
Can you hear me?
Or just
Sorry,
just keep your questions. Keep your questions at the end. Just keep your questions. I will answer every question. You can just
no. What I'm saying
take
is
out
that they are using some ambiguous terms. Kindly break it down to a kind of beginner friendly format.
okay. What kind of terms?
I was hearing some cosine, something.
Okay.
Like I cannot even assimilate it.
Okay. Cosine I don't okay. I understand what you're saying. Cosine similarity, right? If you remember, it's in calculus, right? Yeah, trigonometry. No, it should be in calculus. Where if you want to find this thing, I forgot the exact name of the formula, but it's more of like finding the dot product between two vectors, right? And then dividing it by the distance, by the product of the distance between those two vectors, the normalized distance between those two vectors. I'm trying to remember the mathematics word, but this is actually a maths formula. It's a maths formula, but the term we normally use we call it cosine similarity. That's the term we normally use it, but it's actually a mathematics formula. I don't know. You can look it up. You can look it up. Just look up cosine similarity, right? You can look it up. It's if you see the formula, you should be able to understand it. You should be able to remember it. So um, where was I? Okay, I was talking about the vector DB. Here we have Fairs, then we have Chroma Deep, and then we have Pinecone. Then the retriever, which is another component of a RAG system, which fetches the relevant context. We have the long chain retriever. Then we have the large language model, which generates the final response after collecting the context from the retriever. Then we have that example of the LLMs. We have ChatGPT, we have Llama, we have Mystrify, we have a lot of large language models. Then we have the ranker, which refines search results. So how RAG works. This is a step-by-step process of how RAG works. First of all, you prepare your documents by splitting those data into chunks. You can take a textbook, right? Let's say now you want to build a chatbot that answers mathematics questions. You can take a lot of math textbook and just split each data. Maybe you can split a page into a chunk, into two chunks, and then prepare the document and then store it in a dictionary kind of file, .txt file or whatsoever. It's just about writing codes to split those data into chunks of data because There, there's every large language model has a window context window limit. So you don't want to bombard it with a lot of text. You need to split data into different chunks. Then we have the embedding system, which converts those chunks into vectors, right? And then the indexing stores those embeddings in a vector database, right? I give example of vector database, Pinecone, Fias, RomaDB, and it's the rest. Then we have retrieval, which stretches top K. Top K is more of like the best, the threshold you want to set for your retrieval system. If you want it to return the best three, the best five, the number of contexts you want to use, you want to pass through your large language model. That's what the top K is. It searches the top K and it searches the top K similar chunks per query. Then the generation, LLM reads the query plus the retrieve chunks and then creates an answer. Now, the difference between RAG and fine-tuning. Fine-tuning adds knowledge via retraining, while RAG adds via retrieval. So, let's say you are building a medical chatbot, right? And you have a pre-trained model which is already on the internet, Hugging Face or wherever. Now you have two options. You can either fine-tune it or apply RAG. Why fine-tuning? Why most people actually fine-tune large language models, right? It's very, very resource intensive, such that it requires lots of GPU, and if you don't have enough access to GPM graphic processing units, you need to quantize your model. That is reducing the model weight, right? But with RAG, you don't need to actually do that. You just get the model and just pass in context to it for it to generate. And so I say that RAG is actually more memory efficient and it costs less than fine-tuning. And again, in fine-tuning, you fine-tune a model, a large language model on a particular set of data. If there's a recent trend in the medical field, you still need to fine-tune the LLM again on those data for it to be updated to that current trend. But with RAG, you don't need to keep fine-tuning. You just add the current data into the dictionary of data, and then you keep retrieving your context just for the LLM to generate a response. Now, fine-tuning is expensive, like I said before. RAG is cost-effective. Fine-tuning updates slowly, while RAG updates easily by reindexing data. RAG is ideal for dynamic factual knowledge. Real-world applications of RAG in enterprise chatbots. If you are working in a company and you want to create a chatbot for a company that has access to company documents, definitely there's no large language model that will have access to your company documents. You can create a chatbot that can respond to users' query on things about your company. This is where RAG comes into place. You have a medical assistant used for verifying health records. Let's say you are running a medical organization and then you need to create a chatbot for users. If users need answers concerning their health records or need to just get some information from their health record, you can build a RAG system and add every patient's health records in a dictionary and just be retrieving those contexts via the user's query. Now we have another one, an educational tutor, which retrieves answers or information from textbook to users via a query. Once you query the AI system, the chatbots. Now we have a legal advisor, which analyzes laws and contracts. Then customer support bots, which read frequently asked questions, and manuals. So one of them, we have some challenges in RAG. Definitely, every thing must have a challenge. So if you the chunking means splitting. Say I should break the words. Chunking means splitting. If you split your data poorly, right? That's when you are trying to process your data and prepare it for retrieval. It will retrieve irrelevant results. When passed to a retrieval system, it's going to retrieve irrelevant results. If you use a weak embedding model to embed the the data, the context data from wherever you've stored it, it results to a bad retrieval system. That's why if before you decide on the retriever, before you decide on the embedding model you use, you need to first of all study the niche you're actually working on, right? Now, for instance, now for a medical niche, you are creating an AI chatbot for a medical as a medical assistant, right? You don't use any kind of embedding model, sorry, to as your core embedding model. You need to use a domain specific embedding model, like an embedding model a model that was pre-trained on medical informations prior to your application, so that because now, for instance, now you cannot use a model that was specifically trained for solving mathematical problems as your embedding model for a medical chatbot. It won't be able to capture those informations that is needed when a user asks a question concerning a medical challenge or a health challenge or thereabouts. The model performs weak towards that area because that's not its specialty. Specialty is in maths problems and like latency. Latency means speed. It's speed. That is whether it's slow or fast. Definitely, when building a RAG system, you need to put speed into consideration. A slow chatbot, I don't. It's something that doesn't. You don't need to explain that much because definitely nobody like anything that is slow. Even if your internet is slow, you'll be complaining. So you won't want to build a chatbot that is slow in performing retrieval or performing this thing, generation of response. So you need to look for a light model. When for a retrieval system, for instance, like in FIAS now, we have two types of this thing. You see it in the code. We have two types of index. You have the L2 distance index, and then we have the inner product. The L2 distance is accurate and fast, but it only works well when you have fewer fewer docs in your storage system, wherever you stored it. But in a large scale, it's very, very slow. It's very, very expensive. That's why in companies that applies this RAG in whatever in their system, they normally make use of cosine similarity, right? That's what they normally use. That's what they normally make use of as their similarity search. Similarity search, such that finding information that are similar to the user's query. I should be picking my terminologies. Similarity search, finding information that are similar to the user's query. So that's what it actually means. Then context length limit of large language model. I said it before. Then privacy concerns with external database. So recap, what we have to know is RAG connects LLMs to real world data. The core idea behind everything is just retrieve and generate. Retrieve information from vector DB and generate response using this retrieve context. So that is just the core idea behind RAG. Use this information and answer this question. That's just the core idea behind RAG. Then it delivers up-to-date, factual, and transparent answers. So we are going to do a quick demo. I prepared a small demo, which you can just use to just test things out. Sorry, let me just on this off. Can you see my screen?
Yes, you can see a screen.
Sorry, sir. You can see.
Okay. So I'll be talking about retrieval. Now, let's see it in action. Let's see its work in action. So this is my retrieval system, right? First of all, I hope we are familiar with Python.
Yes, sir.
Okay. So I don't need to be explaining things like classes, functions. Yeah. So this is our retrieval system, and we are using sentence transformer as our embedding model with this model name. This is a lightweight embedding model which we are going to use for this demonstration. So first of all, we have to initialize our model name, the embedding system, and then index, and then ID to text. ID to text is the index mapping. Are you saying something?
Yes, sorry, sir. Please, the model you're using, is this something that we can run locally? The mini LM?
Yes. You need internet connection, actually. Sorry. Internet connection.
And it does need API key, right?
Yes, but I found a workaround just for this demo. I found a workaround using Clarify. That one I'm going to show you. But you need an OpenAI key or whatever LLM you are using. But then I found out about Clarify AI, where it has access to most of this, but it has a limit. So I'm still going to show you. All right. So this embedding model is actually free. You don't need an API key for this embedding model. Sentence transformer is free. You don't need an API key for it. Is if it's open AI this model, you definitely need an API key for it. But this one you don't need an API key for it. It's actually free. So like I was saying, ID to text is just the index mapping of the vector index, because once you've embed the text context, it actually creates a fingerprint in this vector DB called FIAS. It creates a fingerprint which is the index of those vectors. The vectors, it's normally in a dimension, normally in a shape of the number of number of contents you have, and then the dimension. This is actually the shape of the vector once you have embedded it. This D, which is the dimension, can be 128, depending on the model, what the model actually works with. There are some you can actually tune it. You can make it to be 128. You can make it to be 256 the dimension. The higher the dimension, the more it captures more meaning in the document, as in the context of what it has embedded, right? So that's for the init function. Then this build index is what performs the magic, builds the index of each document, each information we have in our dictionary, right? So the embedding, this embedding, it encodes the text. The text is going to you. This is actually, I just prepared um few sample texts. This is actually the text that's going to be embedded, right? I just prepare the sample. Then it's going to, once it embeds it, converts it to a numpy array. You guys know what numpy is, right? Yeah, from that with numpy, that was a mandatory something you should know before coming to this. I don't know. But it converts it to a numpy, and then you can just show progress bars if you want. If you don't want to, you can remove it, right? Then this dim is the dimension. Like I said before, it's normally in a shape of n, which where n is the number of context you have, and then d is the dimension. So the index 1 is referring to the d elements, which is the dimension of the vector. That's so what it does is it tries to create an index from Fias. Fias is a library, and then the function index flat. I was saying something about distance and this thing, also distance calculation. This index flat L2, what it does is it performs a normalized distance between the two vectors, right? The formula is the query vector minus the query vector minus the retrieved context. The query vector minus the retrieved context, then you find the absolute value of it. That's what the L2 distance matrix is actually doing. Then we have another one, which is cosine similarity, which is the dot product between the two vectors divided by the product of the normalized distance of the vectors. You guys should just look up the formula. I'm trying to remember the exact name in mathematics, but it's something relating to finding an angle, something like that. I'm trying to remember the exact name. Can't really remember. So this particular index flat L2, the reason why I use it is because, like I said before when I was explaining, it's actually more accurate in this library called FIAS. It's more accurate, and it works well when you have lesser documents in your dictionary. Once you have lesser documents, okay, it works perfectly well, right? But once it comes to a very large scale, let me say you have about 10,000 chunks of informations in your storage, it doesn't do well because we talked about latency then. It doesn't do well there because it's slow. It creates the index very, very slow, and retrieval gets slow, and who loves the slow system? So after that, then we add the embeddings to the index, and then we try to map each index to the text itself. So the reason for doing this is later on because we are going to be retrieving the text, because the vector database doesn't store what is supposed in its database. It doesn't store this text. So this text is for future use, so that we can see the text it retrieved, right? So then the next function here is query. This query, what is actually doing is this: once you ask the user for a question, okay, what information do you want to know? User will be like, okay, I want to know what this is, what is that, right? The embedding model encodes that user's query. I forgot to say something. Whatever embedding model you are using, make sure you're using the same embedding model you're using for the same embedding model you used in your vector database. Let it be the same embedding model you're using for for the query text, because using two different embedding models definitely is going to capture two different meanings. And if it captures two different meanings, it comes back to what we said before, poor retrieval. Right? So make sure you're using same embedding models when you are using this. So it first of all embeds the query, and then it performs a search, right? Performs a search where D is the dimension. This is the distance, sorry, not dimension, is the distance between the query and the retrieve context. Okay, now in this particular function, the index flat L2, the lower the distance between both of them, the more similar. So the lower between the lower the distance between the query and any of the context, the more similar the context is to the query. I don't know if I make sense. Is it making sense? I need to respond. Is it making sense? Hello?
No, not really from this side.
Okay. What's your confusion?
I think the explanation is not clear enough. The query parts that you were like explaining. So maybe after this, I will take my time and I digest it bit by bit and glance through the recordings and ensure that my time here like means something. So I'm like I will keep on probably not following. Yeah.
Okay. Okay, let me just run through it again. Let me just run through it again. This particular block of code is actually a check to check if this grid index, if it runs successfully, right? Because if it not runs successfully, you cannot perform any query because you have not yet indexed the text. You have not encoded text in the vector database. So this is just a check to check if you have actually run this particular function, which is the build index, right? So now coming over to this line of code, line 31. What this line of code is doing is this: it's taking the question. If you see the arguments, we have two arguments here. Three actually. We have self there, which inherits from the class in its this class functions. Then we have Q, which is the query, the question, whatever you call it. That's Q. Then we have top K. You can you can make it to be 3, you can make it 1, you can make it whatever number you want. And like I said before, top K is the number of best similar contexts you want to retrieve, which is similar to that query. I said it before. That's what top K is, right? So now this line 31, this line of code now, what this is actually doing is this. It's taking the query, right, and encoding. If you see, we passing it in a list because definitely it's going to become an array. So if you just pass it as Q without passing it as a list, it definitely is going to throw up an error because it needs to compile it as an array. So we encode the query, which is the question. We encode it to match the vector. Sorry. We encode the query to match the dimension of the context which we have already stored in our vector database, and then convert to numpy just like we have done before to the other ones. Then the next line of code, where we perform a similarity search, right? We perform a similarity search between the query embeddings and then the retrieved index, the index it, that's the retrieve context from our vector database, and then we select the top 3 because we set our top key to be 3. We select the top 3, and now this returns 2 arrays. D is the distance between the query embedding and then the context, right? The distance so that it performs, it's just minus because since we are using a distance matrix here, it just performs, it does minus between both embeddings and then normalizes it, right? So if we have a I'm trying to see how I can explain this so that you can understand it more, right? But basically this is just the distance between the query and then the context. That's where the context stored in our vector database. So the shape of D is normally this one comma top K, right? Because it's returning just one value. And then one value for each context, one value for each similarity between the context and the query. And then this top K is now the total number. 3, you want 3 of it, you want 4 of it, you want 5 of it. And it depends, it just depends on whatever you want to be. But normally we used to use the 3. Right? That's basic standard. Normally use top 3. Then I is now the index. The index where the text, the index of the text, so that we can just use the I index to retrieve the text from self.id to text. As you see where we did it here. This block of code. What it's doing here is retrieving the index number, then the score. The score is this distance because once you zip this, the distance is for the score variable, and then the index is for this variable. So then we append it to the results. So it's what this is appending now is the index, the score, which is the distance between the query and the context you retrieved. And like I said before, since we're using a distance matrix here, so the smaller the distance, the closer it is to 0, more similar it is the more similar the context is to the query. And then we have the text itself. So this is basically our retrieval system. It's basically what our retrieval system is doing. So I don't know if it makes sense. The person that said it doesn't make sense. I don't know if it makes sense now, or you still have to go through it again. But this is basically our retrieval system. Now, this second final, I made use of Streamlit. You can make use of any front end or any framework you can use to visualize whatever you're doing, right? So I made use of Streamlit. Streamlit is like a drag and drop front end, just like WordPress. Yeah, but you use code to it. Yeah, you use code in WordPress, right? So this is Streamlit. I'm not going to be explaining this essentially because that's not the basic thing. That's not what we are here for. The reason I just wrote this code is for us to just visualize whatever we did here. This is actually the main thing you need to understand. So this is a Streamlit code I wrote for this small demo. So I'm just going to show us some particular place. Okay, yeah. Now this is a sample text I'm using. I'm just using three samples, three texts, right? This one is just explaining what RAG is, this one explaining what Fiat libraries and tracking strategy. So this is just a demo. You can have a lot if you are building something for an organization or you are building a niche kind of chatbot. You can have a lot of documents in that particular niche. So for this demo, we'll just be using this, right? And in this particular code, I made so that you can use this sample text, or you can upload any txt file wherever you have saved. Maybe you've saved 100,000 document content chunks of this information. You've saved it in the .txt file, so you can upload it, and once you upload it, it serves as your dictionary for your retrieval system, right? So now this particular line of code, this line of code, this is actually session. I said I don't want to explain this from it, but let me just explain this. This is just session state. I don't know if you are familiar. If I don't know if you're a web developer, you should understand if we see something about session, something should come into your mind. Saving that particular this in the state of that particular application in saving it somewhere, maybe in your local storage or wherever you saved it. So this session state is simply building the rack system, is building the retrieval system, sorry. It's simply building the retrieval system. If you check here, you see something called build index. This build index is going to run this code, and it normally takes time because definitely you have to download this sentence transformer. That's why once you run it once, you don't run it again. You can start working with your model, start working with them, start querying it and passing it. And even if you change something, whatever you change here, it still retain its states, right? So after building it, it now brings up the it now brings up the page for you to input your question. You input your question. After inputting your question, it retrieves context from your session state, the the document, because once this actually builds, this document has now been embedded and saved in your vector DB. So it retrieves the context here, and then this is where the large language model performs the magic. Call it magic. So what is if you check line 17, this is just a simple prompt because I'm not basically doing something hectic, or I'm going to open another file where I did something like this. You see a very large prompt. This is just a small prompt, right? You are an assistant that answer questions. Use the provide context, the context, blah, and then the question to answer concisely and cite which context you use in your answer. So this is what we were meant to use before ChatGPT, but then I said before that I actually found recently clarify AI. You need an API key, but it's actually free, but it has limit. But like ChatGPT, unlike OpenAI ChatGPT, unlike OpenAI that you need to pay for it, right? So this is our model. It performs, it predicts it takes in the prompt, because the prompt now has whatever you're prompting the AI, the context, which is the documents, and then the query, which is user's question. And then once it predicts it, it generates a response, and then it tries the response. So this is basically just a simple demo. We're going to Actually, I run this symbol. This is should be running. I'm coming. This should be running. Okay. Let me refresh this. Let me refresh this. So if you have any question, you can just ask while this is building. Set.
Okay.
Hi.
Thank you very much, sir. Okay. Chisholm, go on.
Okay, thank you. Hi, Mr. Chidera. Good evening.
Yeah.
Thank you for your whole explanation. So, while you were giving us some tutorial, a question popped into my head. So the thing is, I've built a chatbot before in the past using OpenAI API, but I was having some challenges. The chatbot could answer; it was behaving like a chat GBT. You could ask it any question, even outside the scope of what I was designing it for, and it could give you an answer. So someone told me something about RAG, and I was like, okay, let me try it out. So I was able to like build just like how you have some documents or not documents. I wrote the text like questions, answers, and everything inside the code base, like and but the thing is, even after I did that, the chatbot was still answering some other questions, even when I
That's
tried to
where,
limit it. So how
that's
can
where
I solve that?
okay. Okay. Thanks for that question. That's where prompting comes into play. Okay, let me show you. Let me show
Like
you.
I've tried to do prompts. I've used ChatGPT to also create, like to see if the prompt is going to limit it. It's not working.
It
Once
means
you
you're not
just ask,
prompting.
huh?
It means you're not prompting it well. Come, let me show you something. Let me show you something. Okay. This is a prompt. I made use of LangChain this chat templates. Yeah. This is a prompt. You are PyBot, a helpful Python only assistant that only writes Python programming codes. You are not allowed to respond to questions or requests that are not related to Python programming. You will give it instructions, only respond to questions about Python programming, code debugging, Python related tasks. Avoid any response that are not directly related to Python programming. For any non-Python question, output only this exact line with no additional text, blah, 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 blah. That's for any Python question. If for any non-Python question, this is the default text outputs. That's why I said prompting is very, very powerful. If you, that's why I said prompting makes up 40. I use the word, I use 40%, but it can be more. Prompting makes up 40% of your rack system. If you don't write a very good prompt, you won't get what you want. So you need to rework on your prompt. You need to write your prompt very, and you see it respecting that prompt. Do you understand?
Yeah, I'll try. Maybe I'll build on another one and see because I did all I could and so just giving me issues. Actually, there are some questions you ask you to tell you, oh, I'm not allowed to answer this question. But it will give you that default answer you're supposed to. But when you bring emotional questions, it will just flop and answer you.
That
I
means
even
that means that means that means your prompt is still lacking something. It's still like you find that weakness and just fix it with your prompts.
okay.
That's what you are meant to do. Find that weakness and fix it with your prompts. And you see it respecting your prompt because, like for instance, on this particular application now, I've tested it countless times and it doesn't respond to any question that is not Python programming.
Okay.
So
I'll try that. Thank you.
yeah.
Okay.
So okay.
Good evening, Sir Ferdinand.
Yeah.
Thank you very much for your lesson tonight. So my question, first of all, I've seen agentic AI. We've been doing agentic AI. That was for 2 days now. We talked about nodes. We talked about tools. Then and today we are doing RAG. And then my question is, what basically is the difference between RAG and agentic AI? Because for me, agentic AI is simple, and then you can still give it context. That is, use combined LLM, that is large language models, and then your context may be enterprise logics, and then it will only answer or respond according to the context. And following your class today, it seems its RAC is not quite different from that. It still combines large language models, and then it's constrained by the context you give it. So, from your professional experience, what basically is the difference between both of them? Because for me, RAC is difficult to, it's more mathematical than agentic AI. So, which would you advise and why? What's the pros and cons and the use cases?
Okay. Agentic AI, right? Actually, both of them are there. There's not much difference between both of them. Agentic AI, RAG. Agentic AI is more of like, okay, you want to answer a question, right? But you don't want to answer that question directly. You want to build an agent that answers that question bit by bit. And this is kind of the best explanation I can use right now. You want to build an agent that answers that question bit by bit. Have you made use of this thing, ChatGPT thinking this thing feature? On okay, let's not say ChatGPT. ChatGPT thinking feature is kind of dumb. I'm sorry to use the word. It's kind of dumb. I'm trying to what's the name of this China yeah, DeepSeek. Thank you very much. If you ask DeepSeek a question, try and look at its thinking process, right? That's actually an agent. That's actually an agent working. It takes that question and be like, okay, user wants me to do this. I'm going to split into two different packs. I'm going to split it into 3 or 4 different packs, and I'm going to do each of them one after the other. It does this one. From this one, it gets output is going to use in doing this and the second task. It gets output going to use doing the third task, and so on. So it comes up with an answer. That's actually an agent. But then RAG, it's basically just you're not building an you right this scenario I
So
gave
your
now.
line is breaking. I can't hear you again.
You can incorporate it into RAG. So can you hear me? Can you hear me now? Hello.
Yes, I can hear you now.
Okay. What's the last thing you heard? So I will
Said
not waste my time.
rack is something like that. Rack is that's
Okay. Let me just. You can incorporate agentic AI. You can incorporate agents into RAG, right? You have you have a storage where you stored your text, right? Let's say now you're building an enterprise chatbot that answers customers information, that's what is customer care chatbot, answers questions about your company, products, this and that, and so on. Right. You can incorporate an agent into it using LangChain. Using LangChain. LangChain was not part of what I was meant to talk about today, so that's why you find that I did not use LangChain here. Using LangChain, right? LangChain is a very, very powerful um library. A very, very powerful library used in building stuff like this, right? So like I was saying, you can incorporate it into RAG. All it requires is just building that agent that solves that question, that user query, bit by bit, without the help of the user telling it, okay, do this. Once you don't do this, once you don't do this, it knows what to do. It knows what to do basically just by on how you build the agent, right? So I'm just trying to. I don't want to go technical. I'm just trying to use plain English and understanding
Okay,
to
so if I
explain it with
understand you so far, it means in terms of results, there's no much differences between RAG and agentic AI. And then to some extent, agentic AI can even be better because they have many people working or many agents working to bring out a result, right?
a perfect result. Yes, we can call it that.
It is on maths too plenty.
No, no, you can implement it in RAG. The previous code I was using to explain prompts in there. I actually did it RAG plus building agents using LangChain. So if I don't know if I scroll down, you see where I wrote stuff about prompt templates and creating templates for each this thing. So you can incorporate both of them.
Cooperating both
Imagine
of them is
you
not the
having
problem. Understand where I'm coming from. If both of them can do exactly the same thing and then there's no much difference, it means we have the option of choosing which to use.
your
Except
choice.
there's a particular thing RAG does that agentic AI can't. So that's when I'll now start bothering myself because the libraries you are using for RAG, they are more mathematical. I can see now, I know there will be calculation somewhere. So that's why I was even, can RAG do something better than agentic AI? If it can't, I can stick with Lang chain and simplify my life.
Well, um, actually, it all depends on what you want to build. That's just it. It all depends on what you want to build. Once you've thought about something you want to build, you will definitely know the right technology to use, whether to use agents or build pure rack system. Do you understand?
Yes, sir. Yes, sir. Yes, sir. I do.
Okay. So yeah, I was trying to see where it's still asking me to add open AI key, but I commented it out. Okay, I need to add this thing instead, not open AI key. Um, I'm coming. Once we copy this key from here, okay. Um, if you have any other question, you can be asking why I try to get this working. Sorry. If you have any question, you can be asking. No question. What I said so far, is it clear? Can anyone hear me?
Yes, sir. It's clear. It's clear. It's
It's
clear.
it's clear, like very, very clear. Huh?
Yeah, I'm clear.
Okay. Thanks. I don't think I installed this. I don't think I installed this. I didn't install it. Let me install. Let me add this to the environment. So while we wait for that, okay, this is done. Okay, nice. It should see it now. Oh, I need to remove this. I want to remove this.
Oh, okay. I think you showed your API key by mistake. So when the video is coming out, you
They've
guys should
expired.
Okay.
They've expired actually. Well, you can see blow it out
Okay.
when I've expired. I actually I've reset the shell, so I've used up the OpenAI this credits for that particular API key there. So, but you can see blow it out. Thank you. Um, why is this still? Really? I thought it's just the CMV. Yeah, just the CMV. Right? I'm sorry. Let me show what I'm doing. Yeah, just the theory. So let me just this is yeah. Okay, so let me refresh it and how did I import this? Let me refresh it and run the so you see once you refresh it, it doesn't do that stuff again, the index again because it's already saved in a session. So that's why you see it's running very fast. So let me just ask what is draft. It's okay. It's an issue. Um, I don't know if it's available. Okay. Should I do it instead? Sorry. Let me do this instead. Using get ENV. Get ENV and see it. It's a bit the same thing. Right. Should be the same thing. Let me just finish it. Let me set the you can I made such a way that you can change the number of retrieved documents, whether 1, 2, 3, 4, or 5. Right, so let's get it at 1. It's still so basically what I'm trying done is just for us to see this work. Listen, change yeah, I did not change the distance. What I didn't expect it. Okay, I forgot I'm using just predicts. I forgot I'm using zip codes. Okay. Sorry for the time wasted. If you have any question, you can be asking because once we are done with once this actually works, then we'll actually call it a day.
So thank you very much again for this opportunity. So concerning, you made mention of some database and something I've not heard before, Chroma DB and the rest.
Okay. Yeah, those those are those are vector database. They're vector databases. We have the three most popular ones are FIAS, that is Facebook. The full meaning is Facebook AI Search Similarity. It was produced by Meta. Then we have Chroma DB, another vector database, and then we have Pinecone. You can check it up. Pinecone is actually more simple and straightforward. It's simple and straightforward. This is Pinecone. I use it a lot, but it has limits unless you purchase it. You pay for pro version, and this is Python. Then we have ChromaDB, we have Vice, and the likes. I'm just trying to really predict failed with response, implement supports created, receive an unexpected input type, required ID. I don't get why. Should I use it's why it's like I used before. Ready pipelines, maybe letters, device. Let's use this. Let's use this. Let's see if using this will work.
So please, sorry, which one is the best among those vector stuff, please? Or for people that have
Okay.
been Pinecone?
For beginners, use Pinecone. Pinecone is actually the best for beginners. It's straightforward, easy to use, and doesn't have much complexities. Like, for instance, Pinecone, you can save the embeddings before even um reading the real application. You don't need to save it as you distance you're reading. All you have just is once you've saved it before, once you're already reading your application, you just call it wherever you've saved it, right? If in one of the applications I did before, I used Pinecone, I did not start building all this build query. I just had one function as my retrieval system, which was just this. It retrieves the context from the database itself, where the Python database, and then performs the similarity search. So for beginners, I would recommend using Python. Right? It's easy to learn, easy to grasp, and straightforward. Then you
Okay,
can try using ChromaDB. Huh? Oh, I've exceeded my
I
limit.
also wanted to ask,
Yeah, what do you want to ask?
when you're working maybe something on a recommendation board, customer support, is the best thing to use things like this RAG? Is that what is okay? And I heard
Yes.
is Clinton saying something about LangChain. Is it that LangChain can be used instead of this RAG? I don't really understand.
You no. You use RAG. You use LangChain. You use LangChain with RAG, right? LangChain is more of like it's a library. It's a library, right? Where you can use LangChain in building and this prompt templates,
Please, is it me or is he
agents.
breaking? Can anybody else hear him?
Talk about ASP before. You can use LangChain in doing
Please, can any other
all
person
this,
hear me clearly, or is it my network?
right? Something must explain. Otherwise, you don't hear me. Can you guys hear me?
I think you've been breaking for a while.
Oh, MTN at work. MTN. Oh, fuck. Can anyone hear me? Okay, since it was network. Um,
I didn't really get anything you said on LangChain and Vector.
okay. I said LangChain is a library, right? And you use it in building sophisticated retrieval systems, agents. You can use LangChain to design your prompt templates, right? Basically, LangChain is basically for building agents. You get basically use it in building those kind of stuff, right? And like I did before, you can use it building a better retrieval system to LangChain. You can use LangChain to you can use it to design your prompt templates, right? So it's something you use together with RAG. It's not something you use independently, unless you are not working with a RAG system. You are just using I don't know what is wrong with my network. It keeps kicking me out. Um, let me let me explain what I was explaining before. So, like I was saying, can you hear me? Yeah. Like I was saying before, I said LangChain is not something you use independent. It's not something you use. Yeah, you can use it independently. That's if you're not building a rack system. That's if you are just using whatever the large language model have learned as what it was trained on. You don't want to add additional context like that or thereabout. So you can just use LangChain for building, but it's basically for building agents. Use LangChain basic for building agents. If you're working with a rack system, you can use it to build a better retrieval system. You can use it to build a prompt, a structured prompt template because we have this thing, some templates from the LangChain library. We have system prompts, just prompts, human prompts, things like this. So it's basically in that agentic AI part. Right? But then if you are not using context data where you've stored in a vector DB thereabout, introducing it to your system, it's becomes a more better AI system. So that's basically that's just basically it. You can use it together with RAG, you can use it independently. That's if you are just relying on just the LLM trained knowledge. The LLM's knowledge, sorry.
Okay, thank you. So I want to also understand if I'm using RAG, does that mean that there's no much need for the LLM like that? Like all these API keys, there's no need for it. I just load it with my data.
There is no there is because you need an LLM to generate response. You can't just generate response like that. Like I said before, it's there's a chain, there's a linking chain in a rack system. The user's query, right, which goes through a retrieval system to retrieve similar context. Since that context that are similar to that user's query, and then passes it to a generation model, a large language model that generates outputs. So what's output? Clear? Can anyone hear me? Can you guys hear me?
Yes, please.
Okay.
Yes.
Okay.
Thank you.
All right. So I used up my limit. I don't have used up my limits. I did not have used up my limits. So I could not. I forgot I'm not sharing my screen. I know I used up my limits, right? Show you the context of retrieved. Sorry about um to see if I not exceed the limit because there are different models in Clarify AI. There's Open AI, there's this thing, there's Llama, there's Mistral AI. There are a lot of them. So If you check here, these are the retrieve context and the order of the context that was retrieved. We asked the question, what is RAG? Right? Now, this first index, which is the first context that has a score of 0 points. Like I said before, as for a distance matrix when performing indexing, as it tends to 0, as it gets close to 0, it's similar to the query itself. So you can see that it retrieved network error. Let's just continue. You can see it retrieved information that was in that first dictionary we are using for this demo, which is definition of RAG, right? With a score of 0.9123. And okay, if you check the second thing it retrieved another one which is also low, but this one is a definition, the perfect definition of which is RAG, right? If we add something like index this first, let me show you. Tell us more about. You see, are you seeing the indexing? It indexes this one first because this one is self, and then this one comes next, and then she's just talking about RAG. Apart from it, so in this, what I'm going to do is this: it takes this context now. Depends on the top key this thing demo. We can just set it to be 1 to just get the best out of it, since we're working with small data. But if it's something like you have 100,000 or a million informations which you've stored already, you can get the top 3 and it uses this context to generate an answer. So it's more of like just telling it, Fiat is a library for nearest neighbor search at blah blah blah. This, and then this. We'll have to end. We'll have to end right now because network is now becoming unbearable. I don't know what network. So with this, we'll come to the end of today's session, and I believe everyone understood what RAG is all about. If you have any question, you can. If you have any other question which needs answers to, you can ask it in the group as we end this call. Felix, over to you.
All right, thank you very much, Ferdinand, for the wonderful session. Um, One thing about RAG is just basically giving a knowledge base to your AI. You know, those things that the AI doesn't don't have. You can build your company's data, your personal data, and then the LLM can actually use it to do what? Give you a response. Thank you for that wonderful class. And we also had a UI to actually test. All right, so that was a very good one. So I don't know if you've been taking a lot of questions. Sorry, I don't know if anybody still have any questions to ask. All right, I don't know if anyone still has any question because I was already taking much questions. So please, Ferdinand, maybe after this call, if you can forward the code to me, the code for today's class, or I will send you the link to the repo. It's open. You can commit today's class there. So I see it's you have some packages. Maybe it can be in a folder, name it day 3, and also commit it there so that maybe persons can also test it out. Please, if your model URLs or your API keys and the code, you know how to take good care of them. It's very necessary so that you won't be exposing them. So take good care of them before you push it to the repo, and persons can actually look at it and then try out the codes on their time. So we also make the video available very soon. Both the yesterday's video and today's video, I'll make both of them available at the same time so that we can look at it. And then let's not forget that tomorrow we'll continue with adding memory to our AI. So we're going to add memory to our AI and kind of build some chatbots and do few things on it. So keep in touch tomorrow. Tomorrow is another day. Tomorrow we hit the ground more heavier and running. Thank you very much, Ferdinand, for today. Thank you, Ifani, which is one of us that is here. And we'll give a shout out to all the communities that are making this possible. The Python Anambra Techies, Machine Learning Uyo, Computer Vision Africa, and to all our participants all over the world. So we'll say thank you for joining us. At the absence of any other question, we shall be calling it a night today. Thank you very much, guys.